This week, I want to tell you all about the uArm Swift. At $500, it's less than half the price of the uArm Swift Pro, and that's because it's been built with servos instead of stepper motors. Now, $500 is a bargain for a robot arm of this build quality, but with that cost savings, you lose some of the precision and repeatability. So I thought this might be a good chance to put these two robot arms head to head and show you exactly what that loss of precision looks like. Today's test will be performed like all serious tests, with pencil and paper. I've outfitted both of these arms with the universal holder, which is what they call this attachment here. Basically, it's just a clamp that'll hold a pencil or a marker, just about anything that you can cram in there. So I'm going to give each of these robots a pencil, and then I'm going to put a piece of paper in front of each of them and tape that down to the table because neither of them have an extra hand to hold it steady. All right, so first we're going to be testing the repeatability of both of these arms. And for all these tests, I'm going to be using the offline teaching mode. So these arms can both learn movements just by using a series of buttons that are on the base of the unit and then moving it manually. And it'll actually learn those movements and record them and play them back. So I'm going to start with the uArm Swift Pro. And I'm just going to draw a big plus sign and a circle. So that's taught. And I'm going to do the same thing now with the uArm Swift. It's a little bit harder to move because of the gear reduction in the servos, but it works basically the same way. Now, the quality of the drawing doesn't really matter, it's the repeatability is what we're looking for here. So now I'm going to flip these papers over because I only want to compare the output to itself. There could be some drift between what I programmed in and what it learned, but there shouldn't be any drift between different loops of the same program once it's been learned. So we'll have a blank canvas. Okay. So here are the two pieces of paper from each of the robots, and these will tell us something about the repeatability on both of these systems. Now, putting aside for a second the fact that this one has basically drawn a square where we programmed a circle, just looking at where these lines all fall on top of each other, the uArm Swift Pro has essentially drawn over the same line repeatedly. It's kind of hard to tell that it drew this more than once. Whereas if we look at the uArm Swift, there's quite a bit of spread between the different passes of what are supposed to be the same lines. And part of that is because the servos simply have some rack in the system. The gears and all of the gear reductions necessary to use the servos makes them just a little bit loose, so the angle of approach before it makes a motion actually matters as to the precision of that motion. And you don't have that same problem with the way that these stepper motors are geared. There's also a difference in precision or resolution between these two machines, which is part of the problem here. And to better illustrate that, we're going to do another test. For this test, we're going to be looking at the precision of both of these robots. So what I'm going to do is I'm going to train them both to draw a series of concentric circles, starting from very large to very small. I'm also going to be drawing a series of lines, starting very close together on one side and getting farther apart on the other side. What we should see is that the machine with the lower resolution will start to turn those circles into polygons as they get smaller. because it'll be able to record fewer points and make a less smooth curve. And with the lines, we should see the spacing between those lines vary quite a bit on the machine with the lower resolution. So let's go ahead and give it a shot. I'm going to start with the Pro model. Here's my circles, and I'm going to draw my lines. Beautiful. And now we're going to do it the same thing with the Swift. Good enough. All right. And now I'm going to flip these pieces of paper over and we'll run the test. All right, let's look at the results. Now, looking at the results, it's pretty obvious that there's a massive difference in resolution between these two robots. On this side, we can see that the uArm Swift Pro basically replicated the original drawing. On this side, the uArm Swift has turned all of those circles sort of into a series of squares. All of the elements are still here, and actually the fact that it's dragging the pencil so sloppily along the paper speaks to the vertical resolution. It simply couldn't record the height that I was holding the pencil as well as the uArm Swift Pro was able to. Now obviously there's a big performance difference between these two robots, and the numbers bear that out. The repeatability listed for the uArm Swift Pro is 0.2 of a millimeter, whereas for the uArm Swift, it's 5 millimeters. That's a difference of 25 times. So that's pretty big, but on the other hand, this robot is $800 cheaper than this robot. And if the $800 difference is between this and this, well, this might just work for a lot of applications. If you need to move bulk materials from one location to another, the repeatability of this robot is going to be just fine. If you want to do things like drawing, laser cutting, or 3D printing, you're probably going to need the precision that comes with the uArm Pro. We've talked about the differences between these two units, the price, the repeatability, the precision, but they actually have a lot in common. They both have the same range of motion, they both have 4 degrees of freedom, and they're both rated to manipulate a payload up to 500 grams. They both also contain a vacuum pump, and as such, they come with these suction ends. They also both come with these servo-driven grippers. For $800 difference, you're not losing a whole lot going with the uArm Swift, as long as you can afford to lose the precision from the uArm Swift Pro. So that's the uArm Swift and the uArm Swift Pro. At $500 and $1,200, I would consider both of these powerhouse robots in their respective price ranges. It's up to you to choose which one will fit your application the best, but in both cases, you're getting a lot of robot for the money. They're both precision and repeatability. Both of these robots, of the uArm Swift Pro, it's a lot to say all at once. Now obviously there's a pretty big, price is less than half. All right, here we go.